This lesson is section 5.5, and we are working on graphing systems of inequalities. Inequalities means there's not an equal sign, there's a greater than or less than. We do it very similarly to graphing systems of equations where there's an equal sign. This is the procedure, super quick. For each of the inequalities, you do the following: use a different color. You graph the line, treat it like an equation with an equal sign. And you can either find the slope and y-intercept or the x and y-intercepts, and then connect them to get the line. Sorry about the dog with a squeaky toy in the background. Then, when you're ready to graph the line, you have to decide whether it's going to be dashed if you have a greater than or less than without an equal sign, or solid if you have a greater than or equal to or less than or equal to with the equal bar underneath. Then pick a test point, plug it in, and shade the appropriate side of the line like we learned to do when we graphed inequalities. Finally, you shade the region where the two colors overlap in a different color. This is the solution region for the system. So here's the first system. So let's label this top equation A, so I can work with it over here. I'm going to treat it like an equation. So let's do this one by finding intercepts. So if I plug in 0 for x, I get a y-intercept of 5. And if I plug in 0 for y, I get an x-intercept of 5. So an x-intercept of 5 and a y-intercept of 5. And I'm going to connect those to make my line. And I also have to decide if it's solid or dashed. So let's look over here. There's an equal bar underneath, so that must mean it's solid. So I will connect those with a solid line. Then we have to decide where to shade. So we're going to pick a test point. So 0, 0 is a good test point as long as it's not on the line, which it isn't. So if I plug that into the original inequality, not after any work, because you don't want to carry mistakes over. So that says 0 less greater than or equal to 5. That's false. So we don't shade the side that includes the test point 0, 0. We shade the other side. So if I color code and make this inequality blue, then I'm going to shade the side that doesn't include 0, 0 blue. So that's that shaded region. Now let's move on to the second inequality. I'll call that B for the purposes of keeping track. I'll do my work over here. So I'm going to find intercepts again. So if I put in 0 for x, I meant to make this an equal sign for the purpose of just finding the line. Divide by -1. So the y-intercept is -3. And then plug in 0 for y. So the x-intercept is 3. So the x-intercept is 3. And the y-intercept is -3. And then we're going to go back up here and decide if it's solid or dashed. There's an equal bar under the inequality sign, so this is solid. Let's do this in a different color. So I'll use pink for this one. So first we're going to graph the line, and it's going to be a solid line. So I'm going to connect those two intercepts with a solid line. And now I need to do a test point. So 0, 0 is also a good test point for this inequality because 0, 0 is not on this line. So I plug it into this inequality, so I get 0 minus 0 is less than or equal to 3. 0 less than or equal to 3, that's true. So I want to shade the side that does include 0, 0, so this side. So I will do that in pink. So we get that shaded region. And then the final answer, so the final solution, I'm choosing a different color, is the region where they overlap. So the pink and the blue overlap here. So this region over here is the final solution. Let's do the same thing for this next example. So I will label the top inequality with the letter A just to keep track. I'm going to write it as an equation with an equal sign for the purposes of graphing the line. I'll use a different method and I'll solve for y to find the slope and y-intercept. You can use either method. So the slope is -2 and the y-intercept is -4. So put the y-intercept on here at -4 and we'll go down to right 1, down to right 1, which is the same as up to left 1, up to left 1. And then we're going to connect it with a line, but let's go back up and figure out if it's solid or dashed. There's not an equal bar, so this will be dashed. So make sure I get a dashed line. Okay. And then we need a test point. 0, 0 is a good test point because it's not on the line. So plug it into the inequality. So 2 times 0 plus 0 is less than -4, 0 less than -4. That's false. That means I shade the side that does not include 0, 0. So if I code this pink, I'm shading the side that does not include 0, 0. So over here. So we'll shade this side over here. And now we'll work on the second line. So we'll call this one B for the purpose of keeping track. So I'll write it as an equation with an equal sign for the purpose of graphing the line. I'll use my other method and solve for y to find the slope and y-intercept. -x plus 4 divided by -2. Y equals +1/2 x minus 2. So the slope is 1/2 and the y-intercept is -2. So the y-intercept is -2 and the slope is 1/2. Up 1, right 2, up 1, right 2, down 1, left 2, down 1, left 2. And I'm ready to graph this line. Let's go up here and decide if it's solid or dashed. There's an equal bar underneath, so that's solid, meaning included. So I graph this with a solid line. Then we want to do the shading. So if I make this one blue, I need a test point. 0, 0 is also a good test point because it's not on this line. So I plug that into the original inequality. Don't carry mistakes along. So 0 less than or equal to 4, that's true. That means I'm going to shade the side of this line that does not include 0, 0. So the other sides are over here. All right. And then the final answer, the solution, would be the region where they overlap. So that would be where the blue and the pink overlap. So that would be over here. So that's the final solution region. So now you have one to try. So pause the video, try this, and unpause it when you're ready, and you can see if your answer is correct. So now that you've done the U try, you can verify that your answer is correct, and you can also see all of the work if you need to check any of your work.